Wait.
ln both sides. What's wrong?
Not my calculator messed up.
Drop your phone.
Ln y equals ln x to the square root of x, which means you can bring down the square root of x in front of your ln.
See, this one's not me.
Okay. Derivative of natural log of y.
1 over y dy dx.
Equals the first times derivative of the second plus the second times derivative of the first now multiply both sides by y. In this one, it's not too bad to plug in the original. Here you have root x over x, and then you have plus natural log of x all over 2 square roots of x.
No.
And if you really wanted to, you could clean that up algebraically. You go square root over an x, so you get 1 over root x. Or you could have x root x, and you could make it 2 plus natural log of x. Because if you get a common denominator, this means you need the 2. And you get 2 over root x.
It's okay.
I was just showing you. Pretty much the rule of thumb is if you have a function to an exponent that is another function, then you have to ln both sides. So, you have a chain rule in this problem, as well as a product rule. Because you have the natural log of the natural log. So, like you have a function inside a function, which is a chain rule.
Yeah.
So, you get 1 over y dy dx equals the first, which is cosine x, times derivative of the second. So now, when you derive the natural log, it's 1 over the inside times derivative of the inside, or the denominator, which would be 1 over x. So we took the derivative of the outside, which was all of this. Now you have to take the derivative of the inside, which is 1 over x. Plus the second and derivative of the first. The derivative of cosine is multiply both sides by y. There you go. this is an a to the u. So this is the rule that we did the other day. Or you can natural log both sides. It's kind of like a choice at this point. So whichever one you think is easier. But this is the rule from the other day where it's a to the u. So your rule for a to the u is dy dx equals the original times the natural log of the a times the derivative of the exponent. So and it would have been a negative times a negative, which turned it back to a positive. And then to just simplify algebraically, it'd be like natural log 5 negative 1 over x, all over x squared. Actually, you can drop that down if you wanted to. Do you want to see it if you ln both sides?
Yeah.
So, like, if you ln both sides, you have ln y equals ln 5 negative 1 over x. So you get ln y equals negative 1 over x, natural log of 5. So derivative of natural log of y gives you 1 over y dy dx. First comes rid of the second plus the second times rid of the first. And then you multiply both sides by y, you get dy dx equals y times ln 5 times 1 over x squared. But we know that y is that 5 to the negative 1 over x. Ln 5 all over x squared. So do you see how you actually get the same answer?
Yeah.
So if you forget the a to the u rule, you now could just ln both sides. The a to the u rule is much shorter, but the idea is that if you don't have that rule memorized, or you forget it, the application of natural logging both sides will work. Okay? Example 5. Go ahead and take a minute and set this up algebraically on your own. We're doing a lesson, so that's exactly how I'm going to do the problem. But the idea is that it's y equals x ln half times natural log of x. By ln'ing it, you like made it a lot harder on yourself, because then you had like the ln y, and you have to like simplify it. Where that's all it was.
Yeah.
It was a product rule. So I mean, yes, did I technically like try to trick you into making you ln both sides? Yeah.
Nice try.
But that's what I said. Like it's not wrong. Your algebra and your math could be right. It's just that you have to simplify it algebraically to get to it. So the whole purpose sometimes is to make you realize that like the rules and the patterns, you don't want to follow them to a T. You want to be able to look at a problem and be like, oh, that's a product rule. I don't need to make it easier. So it's first times derivative of the second plus the second times derivative of the first. So now you have x to the 1/2 over x plus natural log of x over 2 square roots of x. And see, here's the thing. Like, I think algebraically, if you did it the other way, you could ultimately simplify yourself down to this. Because even I could say, okay, well, this needs that 2 plus ln of x, and I'm going to end up with 2 square roots of x as my final answer again.
Yeah, like I would have that on the inside over here, and I still have that y on the outside. You know what I mean? Like in my parentheses, I have that. Then you still have the y times.
You want to know why?
Yeah.
So if you ln both sides, you would have had ln y equals ln x to the 1/2 ln x. So for your next line, did you break these apart or did you do a chain rule? Okay, so then you have 1 over y dy dx, right?
Yeah.
So then the rule would be 1 over all of this, and then you took the derivative of the inside stuff, right? You forgot the rule for a natural log is 1 over, because now what happens is when you multiply by y on both sides, this and that cancel, because they're both equivalent to 1 over y. And then you would end up with x to the 1/2 over x plus ln x over 2 squared root of x.
Oh, yeah.
You just forgot 1 over this inside piece, that's all. And then it would end up canceling with your y. So you would ultimately get to this. Alright, I have problems in the book. Don't listen to that because I already did some of those 28s. So,